So in 7.3, we are going to be working through probabilities, and we're going to start off with a lot of definitions here with our probabilities. So probability is the likelihood or the chance that something is going to happen, and we describe it by saying it's a number between 0 and 1. So this is our probability of this event, and if something is very unlikely to happen, then the probability of that happening is close to 0. It's going to be a very small number, close to 0, if it's very unlikely to happen. However, if something is almost guaranteed to happen, it's very, very likely that this event will happen, then that probability of that happening is close to 1. So the closer to 1, the more likely it is to happen. The closer to 0, the more unlikely the event is to happen. Some quick examples here with this. If I were to randomly pick one student from your Math 139 class and ask if they have either a smartphone or a laptop, that probability is probably pretty close to 1 because most of you, I am assuming, have one of these two things. It's very likely that almost all of you have either a smartphone or a laptop, if not both. However, though, if I were to instead ask the question if you have $100,000 in a checking account, that probability is close to 0. Because it's very unlikely that I would get a yes answer. I would most likely get a no from each and every one of you. And then lastly, if something has to occur, there's no other option, then that means the probability is exactly 1. That it is exactly equal to 1. It has to happen. This is essentially 100% of the time this event will happen. However, if something is impossible, it cannot occur at all, then that's when the probability is exactly 0. It's impossible, it can't happen, there's a 0% chance of this event happening. Okay, so next we have a definition here of equally likely. In this class, we are only going to be looking at probabilities that are equally likely or have equally likely outcomes. And equally likely essentially means that the chance of any one outcome is just as likely as the chance of any other outcome. Essentially, if we think of this with a coin, a fair coin means that you have just as likely of a chance of getting heads as the tails. We're only going to be looking at fair coins. We're not looking at cases where maybe someone has made a coin to have it be weighted a certain way, so it almost always lands on heads or something like that. We're not looking at those. We're only going to look at our equally likely cases of these. Similar with our six-sided die, we're only going to be looking at fair six-sided die, where they're your chance of getting a 1, 2, 3, 4, 5, or 6 are all the same. They're not different from each other for this. So we're not looking at dice that someone has made to be weighted to always get 6s. We're only looking at fair dice. Okay, and then lastly, we have some terminology or shorthand notation that we use for probability a lot of the time. So probability of an event E happening, we write this shorter as being P of E. And I would just say that as being probability of E, but we don't want to write out all the words all the time. Similarly, we are going to be talking a lot about the number of things in our events and sample spaces. So number of things in our event E, we're going to shorten that as being N of E. And then a number of things, number of elements in our sample space, we're going to shorten that to be N of S. So then lastly, to get our definition of the probability of our event E happening, so probability of E, well, this is simply just equal to the number of things in our event divided by the number of things in our sample space. So now let's do an example with this. We have that a fair die is rolled, and I want to find the probability of the following events. The first thing that I need with this is my sample space. So when we roll a single six-sided die, our sample space is the numbers 1 through 6. And now, if I look at part A, it asks me to find the probability that the number showing is even or odd. So this means the things in my event is going to be all of my numbers from my sample space that are either even or odd. Well, if we just think about that, that is going to be all of them. So 1, 2, 3, 4, 5, and 6 all satisfy that criteria of being even or odd. So now my probability of this event happening, well, how many elements do we have in our event? We have 1, 2, 3, 4, 5, 6 different elements in there. So it's 6 divided by how many things are in the sample space. Well, we can count that up. We have 1, 2, 3, 4, 5, 6 different options in the sample space. So its probability is 6 over 6, which then we can just simplify that to say that this is 1. And now we can think through this and see that that makes sense, because when you roll a die, a six-sided die, you're going to get either an even or an odd number. It's going to have to be one of those two. There's no other option. So the probability is 1 because it has to happen. The next one, we have what is the probability that the number showing is less than 1? Well, this event, what can I grab from my sample space that's less than 1? There's nothing to put in there. So I don't have anything in this event. It's empty. So my probability of this event, well, how many things are in the event? There's 0 out of my 6 things in the sample space. So this probability of this event happening is 0. And that makes sense. When you roll the six-sided die, you're not going to get a number less than 1. That's impossible. So this probability has to be 0. And then lastly, what is the probability that the number showing is greater than 1? So now this event, I'm going to take all of my outcomes from my sample space that are greater than 1. So we have 2, 3, 4, 5, and 6. So our probability of this event happening, well, how many different outcomes do we have in the event? 1, 2, 3, 4, 5. So we have 5 out of our 6 in the sample space. So this probability is 5/6.